Growth factors like basic fibroblast growth factor can stimulate endothelial cells to grow and proliferate. This results in angiogenesis into the wound and faster healing. Previous studies have shown that a single dose of BFGF is ineffective in accelerating wound healing because it is not immobilized at the site of disease. The BFGF diffuses away from the wound. Here, BFGF was modified with a chitin binding domain by adding a gene for the chitin binding domain into the cells that were also producing BFGF. A hybrid protein was made by modifying the DNA of the E. coli that was used to prepare the proteins. A first step was comparing the labeled product to the unlabeled product. The size of the labeled product was bigger due to the chitin binding domain. The BFGF and labeled BFGF were compared in their ability to promote cell growth, but there was no difference. Next, a chitin film was used as a substrate for the bandage. The chitin binding domain BFGF construct was added on top. The chitin binding domain locked the BFGF growth factor in place onto the dressing. This would then be placed on top of the cells. Next, the amount of BFGF immobilized on the bandage was quantified using light. The chitin binding domain clearly increases how much growth factor is immobilized. In addition, there was very rapid release for the product without the binding domain, but the chitin binding domain BFGF has sustained release for more cell growth. Next, the product was used to stimulate cell growth. Cells were added to the substrate and grown for 3 days. At the end of that time, there were many more cells on the chitin binding domain BFGF support material. This shows that the product increases growth of cells. Finally, a wound model in mice was created and covered with the chitin bandage. After 7 days, new blood vessel growth was quantified. The sample with chitin binding domain BFGF had more new vessels.